Good morning, everyone. Welcome to this lecture, circular motion. Now, this topic we started yesterday and we are hopeful of finishing it today. What we had done in the previous class, we had seen that whatever we have learned in linear motion, the same thing will come in circular motion. In linear motion, we had position vector. Here we had angular position theta. In linear motion, we had displacement. Here we have angular displacement. There we had average angular. There we had average velocity. Here we have average angular velocity. Every one of us remember this? Yes or no? Then we had instantaneous velocity. There we have instantaneous angular velocity. Here the relation is also same. Then we saw uniform motion there. Here it is known as uniform circular motion. It has a time period, it has a frequency, and we had seen the relation between time period and frequency. Do we remember this? Yes or no? Okay, then we had seen if the angular velocity is not constant, we will have angular acceleration. Two types of angular acceleration: average angular acceleration and instantaneous angular acceleration. Most of the cases, what we are going to do is we are going to see motion with constant angular acceleration, and these are the equation of motion with constant angular acceleration. Everyone understands this? Yes or no? Everything is exactly similar as to what we had done in the previous class. Yes or no? So what we'll do, I will again give you those things in one place, and I hope that you will remember them ever. So what I'll do is we'll make a table. The first is quantity. What quantity are we talking about in that table? Then we had linear motion. Then we have angular motion or circular motion. In this one table, we will try to write everything that we had done there and everything that we are going to do now. Number one quantity was displacement. In linear motion, it is known as displacement vector, r vector. In circular motion, it is known as, oh sorry, let me not start with displacement. Let me start with position. So the first quantity is position. In linear motion, we called it r vector. Here we are calling it theta. Do we understand this? Here it is known as angular position. There it was known as position vector. The second thing was displacement. Displacement. In linear terms, we call it change in position vector, delta r. Here we call it as delta theta, which is theta 2 minus theta 1. This is final position vector minus initial position vector. I hope you understand this, everyone. Yes or no? Then we had average velocity. This average velocity was this. It was total displacement divided by total time. Here it is average angular velocity. It is total angular displacement divided by total time. Everyone understands what we are writing? I hope everyone is writing this as well. You need to write it so that everything is there in one place. Then we had instantaneous velocity. Velocity at any instant. We called it V vector. It was dr vector by dt. Here it is omega vector d theta by dt. This d theta is a vector quantity and therefore it is a vector. Okay. Then we had uniform motion here. Uniform motion. My velocity is constant. My average velocity is equal to instantaneous velocity. My acceleration is equal to 0. Here we have omega constant. This is known as uniform circular motion. Do we remember this uniform circular motion? Omega is constant. Then we have the magnitude of omega will be same as average velocity. The angular acceleration alpha would be 0. Then we had something known as frequency, time period. Time period is 1 by frequency. Omega is 2 pi by t. And omega is also 2 pi f. Do we understand what we are writing here? Yes or no? Are we getting this or it is going above our heads? The sixth thing was average acceleration. I wrote it like this. Final velocity v2 minus initial velocity v1 divided by t. Here we have average angular acceleration omega 2 vector minus omega 1 vector divided by t. I hope everyone is noting this down. Yes or no? So one more quantity is left. I will write it and then I will give you time. The last quantity that we saw was instantaneous acceleration. Instantaneous acceleration, there it was a vector, which was dv vector by dt. Here it is alpha vector d omega by dt. I'll give you 2 minutes to note this down. If anyone has any problems, anything that you don't understand, didn't understand, please let me know. Let me know once you are done. Have you noted it down, beta? Yes or no? Shall we move on? Yes? Okay. Now we move on and have a quick look at the equations of motion. In first case, we have linear motion. The first equation is V is equal to U plus AT. Remember, whenever we are using this equation, we use them with a sign convention. If we take this side as positive, this side becomes negative. Do we understand this? Yes or no? If we take upward as positive, downward as negative. So remember, all these equations are used with proper sign convention. The second equation is displacement delta R is equal to ut plus half at square. The third equation was v square is equal to u square plus 2 times a into delta r. The fourth equation was displacement in the nth second is equal to u plus a by 2 times 2n minus 1. Remember, all these equations were for constant acceleration or constant angular acceleration, because we have got now two sets of equation. These were the equation for linear motion. We have similar equation for angular motion. The only thing we have to remember is the sign convention. Here the sign convention is anti-clockwise is positive and clockwise is negative. Do we understand this? The first equation is omega 2 will be equal to omega 1 plus alpha t. Second number equation, delta theta will be omega 1 t plus half alpha t square. Equation number 3, omega 2 square will be equal to omega 1 square plus 2 times alpha into delta theta. Equation number 4, displacement in the nth second, angular displacement in the nth second will be omega 1 plus alpha by 2 into 2n minus 1. Do we understand this, everyone? Yes or no? No, yes. Okay. I'll give you 2 minutes to note this down.
Completed, sir.
Completed. Well done. Then comes a question that will check how much we have understood here. A grindstone starts from rest. I hope you have seen a grindstone, which your probably grandmothers or great grandmothers used to use to grind something. A grindstone starts from rest. So that is one thing. So you must note down important points. Starts from rest and has a constant angular acceleration of 4 radians per second square. So angular acceleration is constant and it is 4 radians per second square. What is the angular displacement and angular velocity after 4 seconds? So that is what you need to tell me. A grindstone starts from rest, constant angular acceleration 1 radian per second square. What is the angular displacement, angular velocity after 4 seconds? And your time starts now. Remember, all the questions are simple. Whether we are doing questions of circular motion or we are doing question of linear motion, equations are same. Even the terms are same. The only thing is angular is put before those terms, and hence we get angular velocity, angular displacement, average angular velocity, and so on. 2 minutes you have. Please solve it. Anyone with an answer for this? A, B, C, D. There are 4 options. Option A, B, C, D. Which one? Are you trying or shall I do it, beta? Okay, I'll give you 1 more minute. Okay, anyone with an answer? Anyone with an answer? No. No one got any answer? Okay, then I must tell you how to solve it. What are the things given here? It starts from rest. So initial angular velocity is 0. Acceleration is given as 4. And time is given as 4. I have to find out the angular velocity. How will I find the angular velocity? Which equation should I use? Which equation should I use? Anyone knows it? Which equation should I use? No one knows it? Okay, not a problem. So I should use equation number 1. Equation number 1 is final angular velocity omega 2 is equal to omega 1 plus alpha t. I will put the values. Omega 2, the final angular velocity. Omega 1 is 0 plus alpha is 4. Time is 4. The value of omega 2 is 16 radians per second. As soon as you get it, you actually know the answer is option 1, but let me solve the other part as well. We have to find out the angular displacement. Which equation should I use? Here I should use equation number 2. Angular displacement delta theta is omega 1 into t. Here omega 1 is the initial velocity plus half alpha into t square. Let me put the values here. The angular displacement will be equal to omega 1 is 0, 0 multiplied by 4 plus half alpha is 4 multiplied by time is 4, 4 square. I will end up with 32 radians. That is the angular displacement. I've already calculated the final angular velocity, and that is the answer, my dear friends. It was an easy question. I don't know why you could not do this, but the answer is option A, and that is how it has to be done. I'll give you 2 minutes to note it down. If you have any doubts, please ask me. Everyone has noted this down? Do we understand this, boys? Yes or no? Okay, now I hope that you can solve this question on your own. Let's see who does it for me. Remember, all the questions are simple. The only thing is you have to understand how they are done. The angular displacement of a particle is given by, remember, angular displacement is given by omega naught t plus half alpha t square, where omega naught and alpha are constant. The value of omega naught, omega 0, is 1 radians per second. Alpha is 1.5 radians per second square. What is the angular velocity at 2 seconds? That is what you have to tell me, my dear friends. I hope you will be able to give me the answer. There are 4 options: A, B, C, D, 1, 5, 3, 4. And wait for your options. And I'll give you 2 minutes to solve this.
Option B, sir.
Option B, sir, and option B is wrong, sir. Try it again. Option B is not correct. The correct option is option D. D for Delhi. 4 seconds. 4 radians per second. Everyone got this? Yes or no? Yes or no? Everyone got this? Yes or no? Okay. How are you supposed to do this? You look at this equation and you compare it with the equation that we had made. Delta theta is equal to omega 1 t plus half alpha t square. You understand that omega naught is your initial angular velocity and alpha is your angular acceleration, and we have to find the velocity after 2 seconds. So which equation should I use? Which equation should I use? I should use omega 2 is equal to omega 1 plus alpha t. Yes or no? Yes or no? Well done. Then I put the values. Omega 2 is omega 2. Omega 1. Omega 1 is the initial angular velocity, which is given as 1 radians per second. So I put 1 plus alpha is the angular acceleration. It is given as 1.5. 1.5 multiplied by time, my dear friends, is given as 2 seconds. 1 multiplied by 2. Answer is 4 radians per second. That is the value of omega 2. How many of you got the correct answer? Only 1, 2, 3. What about the others? What we were doing? Okay, well done. I'll give you 2 minutes to note this down, beta. Let me know once you are done.
Completed, sir.
Okay. Then comes the next question. And here is the next question on your screen. The frequency of a particle following UCM. I hope you understand the meaning of UCM. UCM is 50 hertz. Find its time period T and omega. T is time period, omega is angular velocity. So you have to find out T and omega. Yes, so we have, do we have an answer? How do you find the time period T? Anyone?
1 by F, sir.
1 by F. So it is 1 by 50 seconds. You can calculate 1 by 50 and that is your answer. How do you get the value of omega? 2
2 pi by T, sir. Or 2 pi by.
2 pi into F. So you multiply 2 by pi multiplied by F. So your answer is 100 pi radians per second. So these are your answers. So these are the type of questions that come in uniform circular motion. They give you one thing. They might give you frequency. They might give you the time period. And then you might have to find out the other quantities. If you know any one of the quantity, you should be able to find out the other two quantities. Do we understand this? Yes or no? Everyone got this? Shall we move ahead? Okay. Relation between linear and angular quantity. We have seen linear quantities, velocity, acceleration. We have seen angular quantities, angular velocity, angular acceleration. There has to be a relation between them. And now we are going to see what is the relation between them. How do I get the relation between them? Anyone? Anyone has any idea of what is the relation between linear and angular quantities? And we will try to understand this relation by help of this very simple circular motion, circular diagram. A body moving in circular motion, it has a origin, center, and it has a radius. All of us understand this. Now, if the body moves from point A to point B, if the body moves from point A to point B, so what do I do? From point A to point B, this is the angular displacement. Yes or no? Do we understand this? The body was at point A, now it is at point B. This is the angular displacement. Do we understand this? Yes or no? Now, once it moves from point A to point B, it covers a distance. It covers a distance. Can you tell me what is the distance? This AB is the distance covered by the body. Yes or no? This AB is the distance covered by the body. Do we understand this? Yes or no? This AB is the distance covered by the body. We can find out the length of this distance, the length of this path. If we call this length of the path as L, the value of L, the length of the path will be the displacement, angular displacement multiplied by r. Every one of us knows this, yes or no? How do we derive this equation? We derive this equation because the angle which it has turned is always equal to arc upon radius. Have you seen this equation? Angle is arc by radius. The length of the arc is L, the radius is r. Therefore, I can write length of the arc is the angle delta theta multiplied by r. Do we understand what I have done here? Yes or no? No, yes. So this is the distance L that the body moves when the body turns by an angle of delta theta. So this is the relation between the linear quantity. This linear quantity is distance. This linear quantity is distance. This is angle it has turned. And this is the radius. Do we understand this? Yes or no? No or yes? So if someone tells us a body has turned through some angle, we can find out how much distance it has traveled. Remember, this angle must be in radians. You cannot use the angle in degrees because that will not give you the correct answer, because this answer, this angle that you get is also in radians. Do we understand this? Yes or no? This is the first thing that you must understand. The relation between distance and angle covered. The relation between distance and angle covered. I hope everyone is noting it down, yes or no? Let me know once you are done, bacha. Done? Done, everyone? Then we can write the next heading, relation between omega and v. Omega is the angular velocity and v is the linear velocity. Omega is the angular velocity and v is the linear velocity. Suppose the particle is here at point A, the velocity can be like this. Remember, this velocity of this particle is always tangential. Do you understand the meaning of tangential? Along the tangent. Do we understand this? Yes or no? This velocity v is tangential. Now, it is moving in a circular path. The center is O. The radius is r. Its angular velocity. The velocity is upwards like this. Its angular velocity would be like this. Its angular velocity would be like this. Therefore, at point A, the velocity is upwards. If I go to point B, the velocity would be leftwards. If I go to point C, the velocity would be downwards. If I go to point D, velocity would be rightward. Do we understand this? Yes or no? Now there is a relation between V and omega. First, we will write the relation in the scalar form. In the scalar form, magnitude form, you can write V is equal to omega R. The magnitude of V is equal to omega multiplied by R, where V is the linear velocity. You can write it. Your V is the linear velocity. Your omega is the angular velocity. And your R is the radius of the circle. In fact, if you look very closely, if I write the first equation here that we have written, L was delta theta multiplied by R. L was the distance, linear quantity. Delta theta was the angle, angular quantity multiplied by R. So you look at this equation or you look at the second equation. This is the first equation. This is the second equation. Both the equations are similar. L replaced by V and angle replaced by angular velocity. Do we understand this? Yes or no? Do we understand this? Yes or no? There is also a vector relation between them because both omega and V are vectors. So you can just remember this vector relation. It is omega cross R. It is the cross product of omega with R. We will learn more about cross product later on. Right, just now you can just write it because in NEET you will get this straight away as a question, this one or this one or this one. You will get straight away as a question. What is the relation between omega and V, alpha and A? You can just write this relation. Everyone understand this, what we are writing? Yes or no? You just have to remember any one. If you remember any one, all of the above can be derived. This is the relation between omega, angular velocity, and V, linear velocity. Do we understand this? I'm not getting raised hands from everyone. Do we understand this? Well done. That is good. If you have noted it down, then tell me so that I can move ahead and give you the last relation. What will be the last relation between which two quantities? Tell me. Relation between relation between relation between we have seen the relation between distance and theta angle. We have seen the relation between velocity and angular velocity. What should be the last relation? Tell me, fatafat. No one knows it. Okay. I always believe that NEET students are better than JEE ones, but now very quickly this assumption is changing. Now the JEE wala students are doing a lot better than my NEET students. Anyways, things keep on changing because change is the only constant in life. So the only thing that is left is the relation between alpha, the angular acceleration, and A, the linear acceleration. Or I should call it AT. That would be better. AT. Why it is known as AT? It is known as tangential acceleration. Okay. Again, I draw the same thing. I have an origin O. I have the radius of the circle as R. I have a particle here. it is moving with some velocity. Let us talk about the acceleration. It has a tangential acceleration of 80. Remember, I told you about three types of acceleration: tangential, radial. Do we remember this? Tangential, radial, tangential, normal. This is tangential acceleration. The tangential acceleration is like this. Why it is known as tangential acceleration? Now you can understand why it is known as tangential acceleration, because it is always in the tangential direction. Do we understand this, my bacha? It is always in the tangential direction. Do we understand this? Tangential acceleration alpha at 80, and it also has an angular acceleration alpha. And there is a relation between these two. There's a relation between these two, and it is very easy to understand. Tangential acceleration 80 is alpha into r. Tangential acceleration 80 is alpha into r. This is the scalar relation. You can also write the vector relation. The vector relation will be 80 vector will be alpha vector cross with r. Alpha vector cross with r. So if I summarize all the three together, all the three relation together, have you noted down, beta? If we summarize all the three relations together, relation number one, L, distance is angle multiplied by R. Everyone understands this? Number two, velocity, linear velocity or tangential velocity is omega multiplied by R. The vector relation may not come to you, but you can also remember the vector relation, which is not very important for you because they might not give you question on vector relation. But if you want, you can write it as omega cross r. What is the third relation? Tangential acceleration is alpha into r. You can also remember the vector relation 80 is alpha cross r. Have we noted it down, bacha? Now, let me give you a problem from your previous year papers and you will understand what types of problem come and how simple they are. Remember, simple relations will get you simple answers. And this is the first question. A body is whirled in a horizontal circle. The radius is given as 20 centimeters. It has an angular velocity of 10 radians per second. You have to find out its linear velocity. I hope you can do justice to this question. Remember, everything must be in SI units. If you can understand this, nothing like it. Yes, anyone with an answer? Or shall I do it? No one knows the answer?
Option B, sir.
Option B, sir. That is correct, sir. Well done. That is the correct answer. I don't know why everyone is so confused. You just have to find out the linear velocity. So you multiply omega with r. Omega is your angular velocity. It is given as 10 radians per second. Multiplied by the radius of the circle. The radius of the circle is given as 20 centimeters. You convert it into meters. 20 divided by 100. So you can write it as 20 divided by 100 here. And you get the answer as 2 meter per second. That is the answer that we were looking at. Is it so difficult to answer? So I guess you must be able to do this. Yes or no? Everyone understands this? It is very simple. As you can see, there is one more type of acceleration that we need to understand. This is tangential acceleration. The other type of acceleration is towards the center. And we will write the formula for it. Now see, this was tangential acceleration. Do we understand tangential acceleration is towards the tangent? Yes or no? Then there is one more type of acceleration which is towards the center. This type of acceleration is known as centripetal acceleration. It is always towards the center. This acceleration is known as centripetal acceleration. So you note the formula for that. AC. Some people also call it AN or AR. AC meaning centripetal acceleration. The other name is AN, normal acceleration. The third name is AR, radial acceleration. All of them mean the same thing. It is towards the center. And the formula for this is omega square multiplied by R or V square by R. We will do problems based on this, not now, but in the coming chapter after we are done with Newton laws of motion, we will be doing problems based on centripetal or normal acceleration. You must understand that there are two types of acceleration. I have already told you, but still I am telling you this tangential acceleration again changes the magnitude of velocity or it changes the speed. This centripetal acceleration changes the direction of velocity. Do you remember I told you about this? This changes the direction of velocity. Centripetal acceleration changes the direction of velocity. Normal acceleration, centripetal acceleration or normal acceleration changes the direction of velocity. Tangential acceleration changes the magnitude. Remember these. And the last formula that you have to do is this. I will just write this formula here also. Formula number 4, A centripetal or A normal or A radial is omega squared r. The last formula is total acceleration A is under root of at square plus an or ac square. So just I've already given you this formula before. But now again you can note it once more. We will do some problems based on this in the coming classes. Okay, so note this down, and if possible I'll do 1 or 2 questions in the next class. Do we understand this? Okay, then that takes us to the end of this class. We are done with circular motion. 1 or 2 problems I'll discuss in the next class. We are done. Take care. Have a nice day. Bye bye.